Okay, we are starting Unit 5. Unit 5 is where it gets complicated. We are looking at this unit is called Systems of Equations. We're going to be doing a lot of practice. There is absolutely no way for me to get this done prior to holiday break. You absolutely have to pay attention to CO1 and CO2. Ask questions when you don't understand. Otherwise, CO3, 4, and 5 will not make sense. Okay? I still have to have one person take the test, so you will get those back hopefully tomorrow. But grades are updated in JMC.
Can you check them?
Not right now. At the end of class, I will give you time. Okay. So, we're going to talk about types of systems first, okay? There's going to be, this is, I will tell you for sure, without a doubt, on ISASP. All right, so we have 3 systems here. Slope-intercept form, right? What's that one? Standard. What's that one? Slope-intercept. This is just another form of slope-intercept, and standard. Okay. For each system, it says convert them all to slope-intercept form. So we're just going to separate this out. We've got number 1 here. Do I have to do anything with this first one? No, so I just need to convert the second one. So I have 6x plus 2y equals 10. We've got to get him to slope-intercept form. So what letter do I want on a side by itself? Y. So we're going to get rid of the 6x, get rid of the 6x. If this is not something, when I pass back your test, that you were able to do, I think it was CO5, I'm pretty sure it was. If this is not something that you were able to do, I would do a retake on it because you're going to have to do it in Unit 5. So now I have 2y equals negative 6x plus 10. What is it that you'd like me to do next? Divide by 2. So I have y equals negative 3x plus 5. Do you agree with that? Okay. Do I need to convert this system at the top there, that equation? Do I need to convert the bottom one? Yeah, it's not as much converting. But I'm going to distribute that 4. So I have y equals 4x plus 4 minus 7. What can I still do? Jet? So these two right here, I can combine those, right? So y equals 4x, what? Minus 3. So I've got this system and this system. I've got this one with this one. And finally, do I need to do anything to this top guy? Nope. Okay, so the first step, minus that 2x. What is it that you'd like me to do now? What? Divide by 3. So now I have this one with this one. So what I want you to do right now is see all these top ones that we didn't have to change? I want you to graph those on each one of these corresponding graphs. That's all I want you to do. I want you to graph this guy on this graph, this guy on this graph, this guy on this graph. Okay? And I want you to extend the dots as far as you can. Okay, so what I did was I just handed you a colored, oh wait, I just handed you a colored pencil. You just need a color, so there should be enough for everybody. If you need to sharpen it, please do so quick. Okay. Doesn't have to be perfect, just get it sharpened and let's go. Okay, so, all right, now, what we're gonna do is with that colored pencil, you're gonna graph the bottom ones that we just did. Okay, on the same graph. So like this one is gonna go to this graph. This one's going to go to this graph. This one's going to go to this graph. when you're done with that colored pencil from graphing, please give it to one person of the group, and that person, please come put them away. Not throwing them at them. Stop, gentlemen. Okay. So we're going to look at step 3.
Lewis, Youngbear to the office, please. You'll be leaving. Lewis, Youngbear to the office, please. You'll be leaving.
Describe in words how the two lines in system 1 are related. What do you notice is happening here? What are the two lines doing? I would take a look at our content objective. Maybe you can get some words from that. They're intersecting. Would you agree that this group right here in System 1, they're intersecting lines? Would you agree with that?
Yep.
Okay. What's a word that we could pull out from our content objective to describe System 2? Same line. And what's something we could pull out of our content objective for System 3? Parallel. Okay, so what we're focusing on today is being able to look. You're not always going to graph these. Our goal is to be able to look right here and go, okay, these are intersecting. Okay, these are same line. Okay, these are parallel. Okay, so we're going to write these over here. Okay, so okay, so we're going to write those right there. Okay. So let's take a look at these. Let's start off with the same line one. That one I think is really easy to see. Look at your x's, which is your slopes. What do you notice about the slopes?
They're both the same.
They're both the same, so we could say same slope. Okay, now what do you notice about their y-intercepts? So and we've done this before, haven't we? Yep. Back in Unit 1. It was CO3 of Unit 1. Okay, now let's take a look of when they're parallel. What do you notice about their slopes? What do you notice about their y-intercepts? Stop. Different y-intercepts. Because if it would have been the same y-intercept, then it would have just been same line. Now let's go back and look at intersecting. What do you notice about the slopes? Okay, I'm going to stop right there just because what's the only one that's going to have different slopes? Intersecting. So automatically, if they have different slopes, I know that it is intersecting. Now, if I get it where like, oh man, they have the same slope, what do I need to check? Y-intercept. So if it's the same y-intercept, then I know it's same line. But if it's different y-intercept, I know it's parallel. So what's the only one that has a different slope? Intersect. Okay. All right, so without graphing, I want you to write, what do you think this is and how do you know that? What do you think system 4 is and how do you know that? Okay, so what do we say that system 4 is? Parallel. And how do I know it's parallel?
Same slopes, but different y-intercept.
Does this make sense so far?
Yes.
I'm not going to expect you to graph these. What I'm wanting is we're going to get down to putting them both in slope-intercept form is going to be, tell you right now, the easiest. And is it always going to come where they're both in slope-intercept form? No. This is why we had to learn in Unit 4 how to convert. Before, remember when I give it to you in point slope or standard form and I'd say, okay, now convert it to slope-intercept? The reason is because we were coming into this. Okay? Each unit in algebra will keep building and building and building. I'm going to expect you to know how to do things how you did in Unit 1, and Unit 3, Unit 4, and Unit 5.
What a kind soul. Wait, I caught it.
Okay. Okay. All right, let's get started. At the end of the class, I will give you a chance. Actually, I'm going to wait till probably Wednesday, Thursday, to get your tests back to know if you want to recycle anything from Unit 4, because you might want to do retakes and you might need your notes for that. Okay, I can algebraically determine if two lines are parallel intersecting, or the same line. We just looked at that in our Explore and how to do that. Okay? Vocabulary. When I'm talking about a system of linear equations, it means two or more lines in linear equations. I could have multiple linear equations, and I could ask you what's the answer to the system. Okay? We're going to get to the answers of the system in CO3 and 4. Well, we'll really get to the solution in CO2, but I'm going to end up taking the graphs away. Okay, a solution to the system, that's what we'll be getting to on Thursday, is an XY ordered pair, which we will be talking about. All right, let's go ahead and flip over. This is something we just looked at that we've already discussed. If the two lines have the same slope and the same y-intercept, then they are the same line. If they have the same slope but different y-intercepts, then they are parallel. And if they have different slopes, then they're intersecting. It's the only one that has a different slope. Okay. So this is what it looks like. It's just saying that in an intersecting, there's one solution because they're only hit one time, right? Does it make sense that parallel lines would be no solution? Because are they ever going to touch? No. And would it make sense that the same line is going to be infinite many solutions? Because how many times are they touching? Infinite many solutions, right? Infinite many times they're touching. So does it make sense that these would have one, no, and infinite? Yes. Okay. All right, let's dive into our work then today, because we're going to be using all that vocabulary. Like I said, they're never going to be nice, especially in ISASP or FAST testing or ACT testing, which you will do next year. Yep. I took it all 4 years. I have test anxiety. No, I just have test anxiety, and I didn't want to wait till my junior year when I was applying to colleges to take it and realize I got like a 17, and I can't get into college.
What are you supposed to get?
Upper 20s. Shooting around for 24 to
On the ACT?
So wait,
30.
if you
Or
don't
above
get that,
20.
Perfect, like 36, I think.
if you don't get that, can you still get into college?
You may have to go to a community college or take entrance exams. So I took it every year. Okay, so, all right, here we go. Determine if the two lines in the system of equations are intersecting, parallel, or same line. State how many solutions there will be for each system. So, is this guy in slope-intercept already? So I only got to convert this guy. So this is why I said if you didn't do well at converting that CO5 last unit, I'd be retaking. So the whole goal is to get what letter by itself? So we're going to subtract the 4x. Whatever I do to one side, I do to the other. Now I have a question for you because this was commonly missed. What's left over here? Negative 5y. People just like to bring down that 5 and leave the negative. That matters. That's still there. So now I'm going to divide by negative 5. Divide by negative 5. A negative divided by a negative is a positive. Now, do I want you to convert that to a decimal? No. I want you to leave it a fraction. What's positive 30 divided by negative 5? Okay, so here's my two equations. I tend to, guys, I'm not going to lie, I box them in so I know what I'm looking at. So I'm comparing these two. What's the first thing you notice?
Same slope.
Same slope, so what's the next thing I have to check? Y-intercept, and it is? Okay, so what do I say? Parallel? Oops, I just totally did not spell parallel right. Parallel. Now how many solutions does it have then? No solution. And why does that make sense? They're never going to touch. The solution to a system is when the lines meet. That is the solution. It's the XY coordinate when the lines meet. If they're parallel lines, are they ever going to meet? Nope. Okay, let's try this next one. Are either one of them currently, right now, in slope-intercept form? Nope. So I tend to split the page. I'm going to tell you right now, this unit, organization on your paper is going to be key. All right, so let's get these into slope-intercept form. I'm going to add the x, add the x. So I now have 2y equals x minus 6. Is y alone yet? What would you like me to do? So I move my x over here, divide by 2. What number is in front of that x currently? 1. So there's a 1 here. So this is really going to read 1/2 x. Would you agree with that? Then what? Minus 3. So I'm looking, this is one of my equations for my system. I now need to get my other equation. So I'm going to go ahead and distribute. Y equals, what's 1/2 times x? 1/2 times 2. And now I can do what with these two right here? Combine like terms. So when I combine 1 and -4, what do I get? So look at your slopes. What do you notice? What do you notice about your y-intercepts? So what can you tell me?
Same line. Infinite many solutions.
Yep.
Smart guy.
Something like that.
Same line, infinite solutions. And does that make sense why it's infinite solutions? Yeah. How many times are those lines touching?
All the time.
All the time, infinite many. Okay. Let's go ahead and go on to the next one. Okay. Now, I'll wait. They were nice here. What'd they do? They already gave it to you in what? Slope-intercept. So let's just start comparing. Let's look at our slopes. They're different though, so if they're different slopes, they're what?
One solution.
Yep, intersecting with one solution. We're building on this on Thursday. You have to know how to do this because I'm going to build on it. Okay. At the bottom here, your turn. I want you to tell me, A, what is it? B, what is it? right, so I'm going to start converting this. All right, these are the two I'm comparing. What can you tell me? They're different what? Different slopes, so automatically that makes it intersecting one solution. All right, this one over here, I got to distribute. Then combine like terms. All right, these are the two I'm comparing. What can you tell me? Same slope, same y-intercept, so it's same line, infinite. Is this making sense so far? Yes, okay. All right, let's go to the next page. Almost done. A system of two linear equations has no solution. One of the equations in the system is negative 3x plus y equals 1. What do you know must be true about the other equation? First of all, is this in slope-intercept form? No. Nope, let's get it there. I'm going to go ahead and add 3x.
James and Jamie Youngbear to the office, please. You'll be leaving. James and Jamie Youngbear to the office, please. You'll be leaving.
So it has no solution. Stop. So it has no solution. What does that mean? Is it intersecting, parallel, or same line? Okay, so we know it has to be parallel. Okay, so what must be true? What?
Same slope.
It has to have the same slope and what? So I know right now, in that other equation, without a doubt, the slope is what? Without a doubt, the other slope is 3. I know that. Now, can the y-intercept can be anything but what?
Plus 1.
Plus 1. Could it be minus 1?
Yes.
Could it be plus 2? It could be anything but plus 1, because if it's plus 1, what does that make it?
Same line then.
Same line then. And I don't want same line because I have no solution. Okay. All right. A system of two linear equations has one solution. One of the equations is 3y plus 4x equals 2. What do you know must be true about the other equation? Okay. I would get this into slope-intercept form first. Get that into slope-intercept form first. Do you agree with my conversion? Okay, so it has one solution, therefore it's what? It's got to be intersecting. So that means what? Different slopes. Does y-intercept matter? No. So what I know, what do you know must be true about the other equation?
It must be the same line.
Has to be a different, so it can be any slope but what?
-4/3.
Oh.
Can it be anything else?
Yes.
Can it be -4/2? Yeah. It can be anything else. It just cannot be this. Because if it's this, then what? Then your slope's the same, so at bare minimum, it's either it's either parallel or same line. Because what's the only one that has different slopes? And how many solutions does that have? One. All right, I promised you I'd leave you some time to check your checkup scores, so go ahead and do